Alright, today's video is for two-step equations. This is Blue Chapter 12.1, and your essential question comes from page 679 in your textbook, page 679 in the blue textbook. It's explain how you decide which inverse operation to use first when solving a two-step equation. Explain how you decide which inverse operation to use first when solving a two-step equation. Again, that comes from page 679 of your blue textbook. Alrighty, let's start with our first example. We have 2n plus 5 equals 13. Now, what you've been doing up to this point is you only had the n plus 5, or you had the 2n equals 13. You didn't have both. So what you have to decide is which operation are you going to undo first. So the rules for deciding which inverse operation to do first is follow PEMDAS backwards. Okay? Follow PEMDAS. Remember, PEMDAS is your order of operations backwards. Okay? So that means instead of doing parentheses first, you're going to undo parentheses last. You're going to undo adding and subtracting first. Then you'll undo multiplying and dividing. Then you'll undo the exponents. Then you'll undo parentheses. Okay? So let's go ahead and solve this problem. We've got 2n plus 5 equals 13. 2n plus 5 equals 13. So I'm going to undo I have addition and I have multiplication. So I'm going to undo my addition first if I'm following PEMDAS backwards. Remember, I want to start on this side and move backwards. If I undo the addition, I'm going to subtract 5. And remember, we do this from both sides. One really helpful thing to help you keep organized, what I like to do is I like to draw myself a little jail bar like this, separating what's in the problem and what's on the equal side. This will come in real helpful later when you have more information over here besides just a number. And then I also like to draw a little line right there, and that separates my problem from my solution. Keeps you organized. If you don't like it, don't do it. Okay? But it just keeps you organized. So I need to subtract 5 from this side, and I have to subtract 5 from this side. We have to keep our equation scale balanced. We want to keep it even on both sides. If I only subtracted 5 from this side, that would change the problem to 2n equals 13. That's not what the problem was written. Okay? So then I go through, and plus 5 minus 5 will cancel out. I bring down my 2n. 13 minus 5 is 8. And I put my equal sign in there. Okay? So I get 2n equals 8. Now I'm not done because I don't have the n isolated. Remember, the whole purpose of an equation is to isolate our variable, to get it all by itself. This is why it's called two steps. This was step 1. Now I'm going to do step 2. So I'm going to extend my little organization here. Do step 2 in a different color. 2n. When you have a number next to a letter, it means multiply. So the opposite of multiplication is division. So I'm going to divide by 2. You can either write it like this. I don't like to write it like that because it gets a little confusing and messy. So I usually just go divided by 2. Remember, those aren't fractions. That's a division sign. But you can use whichever method makes sense to you. Multiplied by 2, divided by 2. That cancels out, and that marker is awful. Let's try this one. Okay, divide by 2 on the other side. I get 8 divided by 2, gives me 4. Bring down my n equals 4. After you've gotten n equals 4, you need to solve your problem, and you can test it out. You're going to take this 4 and you're going to plug it back in for n. Okay, you're going to take this 4, plug it back in for n. So we go in and we write 2 times 4 plus 5 equals 13. Move my chair out of the way. 2 times 4 is 8 plus 5. Now remember, I'm solving this, so I do order of operations in order. Multiplying in parentheses come before adding. Equals 13. 8 plus 5 is 13, so I do get 13 equals 13, so I know it's correct. Okay? So this one showed multiplication and addition. Let's try a problem that has some other solutions. We're going to try something with division and subtraction in it. All right? I'm going to go ahead and erase.